Somewhere off the coast of Africa 3 weeks ago, a small ripple formed in the atmosphere. You wouldn't have noticed it. There was no swirling cloud mass, no eye, no name, just a subtle dip in air pressure, a gentle bend in the wind field, moving quietly westward over the open Atlantic Ocean at a walking pace of roughly 15 to 20 miles an hour. That ripple has now crossed thousands of miles of open water. It has survived the dry, dusty air blowing off the Sahara Desert. It has pushed through areas of sinking air that try to choke off every budding storm before it can breathe. And now, this week, it has done something that instantly puts meteorologists, emergency planners, and millions of people across the region on alert. It has entered the Caribbean. If you follow hurricane season, even casually, you've probably heard the phrase tropical wave thrown around on the news without much explanation. It sounds almost harmless. A wave, like something you'd see at the beach. But in the world of tropical meteorology, a tropical wave is the seed from which some of the most destructive storms on Earth eventually grow. Not every wave becomes a storm. Most don't. But every hurricane that has ever formed in the Atlantic basin, and every single one, started its life as exactly this. An unassuming disturbance drifting west across warm water, waiting for the right ingredients to align. So today we're going to break down exactly what's happening in the Caribbean right now, why this particular wave matters, what the atmosphere needs to do to turn it into something bigger, and what the coming days could realistically look like for the islands, coastlines, and communities sitting in its path. No panic, no fear-mongering, just a clear, honest look at the science and the stakes. Let's start from the beginning. To understand what's unfolding in the Caribbean, you first need to understand where storms actually come from. It's not as dramatic as people imagine. Hurricanes don't just appear out of nowhere over warm ocean water. They almost always begin as tropical waves, sometimes called easterly waves, because of the direction they travel. Picture the atmosphere over Africa during the summer months. As the continent heats up, especially over the Sahara and the Sahel region, just south of it, you get a sharp contrast between hot, dry air to the north and cooler, more humid air to the south. That temperature contrast creates what meteorologists call the African easterly jet, a fast-moving river of air a few miles above the surface. Because of the way this jet behaves, it doesn't flow in a perfectly straight line. It wobbles, it develops kinks and bends, almost like ripples moving down a garden hose. Each one of those kinks is a tropical wave. They peel off the African coast every 3 to 5 days throughout the summer, one after another, like a production line. Most years, meteorologists count somewhere between 50 and 70 of these waves crossing the Atlantic between June and November. The vast majority fizzle out. They run into dry air, they run into unfavorable wind patterns, or they simply never get organized enough to develop a closed circulation. But a small number of them, the unlucky, or depending on where you live, the very much noticed ones, find themselves moving over warm enough water with low enough wind shear and enough atmospheric moisture that they start to organize. Thunderstorm clusters begin firing repeatedly near the same spot. A weak area of low pressure forms at the surface. Air begins spinning around that low, first loosely, then more tightly. If that rotation becomes organized enough and sustained enough, the system gets upgraded first to a tropical depression, then a tropical storm, at which point it earns a name. And if conditions stay favorable, eventually a hurricane. That is the pipeline. Wave, disturbance, depression, storm, hurricane. And right now, the system making headlines is sitting at the very first stage of that pipeline, having just crossed from the open Atlantic into the Caribbean Sea, a body of water that, for reasons we'll get into shortly, plays an outsized role in deciding whether these systems live or die. The Caribbean Sea is, in many ways, a proving ground. It's where a lot of promising tropical waves go to either strengthen dramatically or fall apart entirely. And the difference often comes down to a handful of variables that shift from week to week, and even day to day. First, there's water temperature. The Caribbean is warm for most of the hurricane season, frequently sitting well above the roughly 80 degrees Fahrenheit threshold that's generally considered necessary to sustain tropical development. Warm water is fuel. It evaporates into the atmosphere. That water vapor condenses into towering thunderstorm clouds, and that condensation process releases heat that powers the entire engine of a tropical cyclone. In this sense, the Caribbean rarely lacks fuel. Second, there's wind shear. And this is where things get complicated this year. Wind shear refers to the change in wind speed and direction at different altitudes in the atmosphere. Think of a storm as a stack of pancakes. For it to grow, all those pancakes need to stay aligned, one directly above the other, so that the heat being released in the upper atmosphere stays connected to the low-pressure engine near the surface. Strong wind shear tilts that stack sideways, ripping the top of the storm away from its base. It's like trying to build a tower out of blocks while someone keeps pushing the top one sideways. Even with warm water and plenty of moisture, high shear can prevent a system from ever getting its act together. And this year, wind shear is a big part of the story. If you've been paying attention to hurricane forecasts this year, you've probably heard meteorologists mention El Nino repeatedly, and for good reason. This year's Atlantic hurricane season is unfolding under the influence of a strengthening El Nino pattern in the tropical Pacific. And El Nino has a very specific, very well-documented effect on Atlantic tropical activity. When El Nino is active, it tends to enhance upper-level winds blowing from west to east across the Caribbean and the tropical Atlantic. That translates directly into higher wind shear across the exact region where tropical waves need calm, aligned conditions to organize. Multiple research teams that specialize in seasonal hurricane forecasting have pointed to this pattern as a major reason why activity across the basin has generally been projected to run below the long-term historical average this year. Some outlooks have placed expected storm energy for the season meaningfully under normal levels, largely because of just how disruptive this El Nino pattern has been to the atmosphere over the Caribbean and the wider tropical Atlantic. In fact, forecasters tracking wind shear in real time have noted that conditions over the Caribbean Sea have, at points this summer, ranked among the highest ever recorded for this time of year. That's a striking statistic, and it tells you something important. The atmosphere this wave is moving into is not the same atmosphere you'd find in a typical, more favorable hurricane season. It's hostile territory, at least for now. That doesn't mean nothing can develop. It doesn't mean this particular wave, or the next one, or the one after that, can't eventually organize into something more serious. El Nino years still produce hurricanes, sometimes even major dangerous ones. The frequency tends to go down, but the risk never goes to zero. And history is full of examples of destructive storms forming during El Nino years that were otherwise projected to be quiet. It only takes one system finding the right pocket of favorable conditions at the right time. So while the broader seasonal backdrop leans toward suppression this year, that's exactly why every wave that manages to survive the trip across the Atlantic and push into the Caribbean deserves a closer look. The ones that make it this far are, in a sense, already beating the odds. So let's get specific. As this wave has pushed westward into the Caribbean basin, forecasters have been watching it closely, alongside several other disturbances moving through the same general region at the same time. It's actually fairly common during the peak of summer to have multiple tropical waves lined up across the Atlantic and Caribbean simultaneously, almost like beads on a string, each at a slightly different stage of development. What forecasters look for first when a wave like this crosses into the Caribbean is organization. Is the associated thunderstorm activity clustering tightly around a defined center, or is it scattered and disorganized, spread out over a wide area with no clear focal point? Right now, this wave has been showing exactly the kind of scattered, broad pattern that's typical of an early stage system. Showers and storms extending across a wide swath of the eastern and central Caribbean without yet consolidating into a tight, organized cluster. That's not unusual, and it's not necessarily a sign the system won't develop. Many storms spend days in this loosely organized phase before conditions allow them to tighten up. What matters most from here is what happens as the wave continues moving west, because the Western Caribbean and the areas near Central America and the Yucatan Peninsula often present a genuinely different environment than the Eastern Caribbean, sometimes more favorable for development, particularly later in the summer as water temperatures continue climbing, and as the broader monsoon-like flow near Central America becomes more supportive of slow, gradual organization. Meteorologists are also watching something called the monsoon trough, a band of low pressure and enhanced moisture that stretches across parts of the tropical Atlantic and interacts with these westward moving waves. When a wave passes near or interacts with this trough, it can sometimes pick up additional spin and moisture, giving it a better chance at organizing than it would have on its own. For now, official development odds on this system have remained modest rather than alarming, the kind of numbers that say worth watching rather than prepare for imminent landfall. But those numbers can and do change quickly, sometimes within 24 to 48 hours, especially once a wave clears the more hostile wind shear of the eastern Caribbean and moves into the western basin or the southwestern Gulf, areas that have historically been late bloomer hotspots for slow-developing July and August systems. Let's break down in plain terms exactly what needs to happen for this wave to go from disorganized disturbance to tropical depression to potentially something stronger. Ingredient 1, sustained warm water. As the wave tracks westward, it will pass over different pockets of the Caribbean Sea, some warmer than others. The central and western Caribbean, along with the Bay of Campeche in the southwestern Gulf, tend to run especially warm by late July, often warm enough to support rapid strengthening if every other ingredient falls into place. If the wave stalls or lingers over one of these warm pools for an extended period, that increases its odds of organizing. Ingredient 2, reduced wind shear. This is the big question mark this year. If shear stays elevated as expected under the current El Nino pattern, it will likely keep suppressing organization, pulling apart the upper structure of any budding storm before it can consolidate. But shear isn't uniform across the whole basin. There can be pockets of weaker shear, even within an overall unfavorable pattern, and systems sometimes find and exploit these pockets. Forecasters will be watching short-range model guidance closely for exactly this kind of localized opportunity. Ingredient 3, mid-level moisture. Even with warm water and low shear, a tropical system needs a humid atmosphere surrounding it to survive and grow. Dry air, often associated with Saharan dust that streams off Africa earlier in the summer, or dry continental air pulled down from North America, can choke off thunderstorm activity by promoting what's called dry air entrainment, where dry air gets pulled into the storm's circulation and suppresses the very convection the system needs to survive. Right now, forecasters have noted that dry air and Saharan dust have played a meaningful role in keeping the broader Atlantic and Gulf quiet this summer, and whether that dry air retreats or persists over the coming days will matter a great deal for this wave's future. Ingredient 4, a favorable upper-level environment. Beyond simple wind shear, forecasters also look at outflow, how well a developing storm can vent air away from its top. Good outflow acts like a chimney, efficiently removing air from the top of the storm and allowing more air to rise from the surface, which strengthens the whole system. Poor outflow, often caused by nearby high-pressure ridges or jet stream interference, can trap that air and stunt development. Put all 4 of these together, and you get what meteorologists sometimes describe as a recipe. Right now, this wave has one strong ingredient in its favor: the warmth of the Caribbean Sea it's moving through, and at least one working against it, the elevated wind shear tied to this year's El Niño pattern. The next few days will show whether the more favorable ingredients, like reduced dry air intrusion or a lucky pocket of weaker shear, manage to tip the balance. It's worth pausing here to talk about why forecasters take these systems seriously, even when the odds of rapid development look modest, because history offers plenty of humbling examples. Some of the most devastating hurricanes in modern memory began as unassuming waves that crossed into the Caribbean looking disorganized, weak, and unimpressive, only to explode into major hurricanes within a matter of days once they found the right combination of warm water, low shear, and high humidity. The Caribbean and the Gulf of Mexico, in particular, have a well-earned reputation among meteorologists for producing some of the fastest, most dramatic intensification cycles anywhere on the planet, largely because of how warm and deep the warm water layer can be in certain pockets, especially later in the season. This is part of why forecasters resist making confident predictions about weak, early-stage systems like the one currently in the Caribbean. Confidence in a storm's ultimate strength and path generally increases the closer it gets to actually organizing, but by the time that happens, there may only be a few days, sometimes even less, before landfall becomes a real possibility for someone. That compressed timeline is exactly why coastal communities and island nations across the Caribbean basin are encouraged to treat every wave season as an opportunity to check their preparedness, rather than waiting for a system to already have a name and a defined track before taking it seriously. It's also worth remembering that a storm doesn't need to become a major hurricane to cause serious harm. Some of the deadliest and costliest tropical systems in Caribbean history never grew beyond tropical storm strength in terms of wind speed. Their damage came instead from something far less flashy but often more dangerous: rainfall. Slow-moving tropical waves and weak tropical storms can sit over mountainous islands and coastal terrain for extended periods, dumping enormous amounts of rain in a short window of time. That rain triggers flash flooding and landslides, particularly across the mountainous interiors of islands like Hispaniola, Jamaica, and Puerto Rico, where steep terrain and saturated soils turn heavy rainfall into fast-moving, life-threatening water almost immediately. So even in a below-average season, even with a wave that never earns a name, the flooding and mudslide risk alone is enough reason for this system to be taken seriously across the region. As this wave continues its westward journey, several regions sit in a position to feel its effects even if it never organizes into a named storm. The Lesser Antilles and the Leeward Islands are often the first to feel the outer bands of moisture associated with waves like this, typically experiencing bursts of heavy showers, gusty winds, and rough surf as the disturbance passes nearby. For islands like Barbados, Dominica, St. Vincent, and the Grenadines and the surrounding chain, this usually means localized flooding risk and hazardous marine conditions rather than a direct, sustained threat, especially while the system remains in its disorganized state. Moving further west, the Greater Antilles, Puerto Rico, the Dominican Republic, Haiti, Jamaica, and Cuba sit directly in the path that many Caribbean tropical waves eventually follow. This is where terrain becomes a critical factor. Even a weak system moving over Hispaniola's mountainous spine, for instance, can produce dramatic, highly localized rainfall totals thanks to what's called orographic lifting, where moist air is forced upward over high terrain, wringing out even more rain than the storm's overall strength alone would suggest. If the wave continues on a track toward the western Caribbean, attention naturally shifts to the Yucatan Peninsula, Belize, and the broader Central American coastline, as well as the possibility of the system pushing into the southwestern Gulf of Mexico. This corridor has, in past seasons, proven to be a favored zone for slow, gradual development during the height of summer, in part because water temperatures there tend to run especially warm and because the interaction between land, sea breezes, and the monsoon trough can occasionally provide just enough spin for a system to get organized, even during years when the broader basin is otherwise hostile to development. It's worth being honest here. At this stage, with the system still disorganized and shear still a significant obstacle, any specific talk of a landfall location or an eventual peak intensity would be premature and, frankly, irresponsible. What we can say with confidence is which general regions carry elevated rainfall and flooding risk over the coming days, regardless of whether the system organizes further. And that list includes much of the Caribbean island chain and portions of Central America's Caribbean coast. It's worth taking a moment to explain how meteorologists actually monitor a system like this day to day, because the process is more methodical and more reassuring than it might seem from the outside. Forecasters rely on a combination of satellite imagery, which shows cloud patterns and helps identify whether thunderstorm activity is becoming more organized around a defined center. Reconnaissance aircraft, which are sometimes flown directly into promising systems once they show signs of possible development, gathering direct measurements of pressure, wind speed, and structure that satellites alone can't provide. And computer models, dozens of them run by different national weather agencies around the world, each using slightly different mathematical approaches to simulate how the atmosphere might evolve over the coming days. No single model is treated as gospel. Instead, forecasters look at how well the different models agree with each other. When most of the major models, the American GFS, the European ECMWF, and others, cluster tightly around a similar outcome, confidence goes up. When they diverge significantly, showing wildly different tracks or intensities, forecasters communicate that uncertainty clearly, often through the well-known cone of uncertainty you've probably seen in hurricane graphics, which expands or narrows depending on how much the models agree. For a system still at the tropical wave stage, this uncertainty is naturally higher than it would be for an already organized hurricane, simply because there's less structure for the models to lock onto. This is exactly why official percentages for development, the numbers you'll hear referenced as something like a certain percent chance over the next 2 days and a higher percent over the next week, tend to update every few hours as new data comes in, and why those numbers can shift up or down noticeably from one advisory to the next. Given everything we've just covered, a system that's disorganized but persistent, moving through a basin that's warm but hostile to development this particular year, what does responsible preparation actually look like at this stage? The first and most important point is this: you do not need a named storm to justify basic preparedness. Hurricane season. Preparedness isn't something that should switch on only once a system earns a name and a defined forecast cone. If you live anywhere across the Caribbean basin, Central America's Caribbean coast, or the Gulf Coast of the United States and Mexico, this is a good moment to do a quick, practical check-in on your own readiness, regardless of what this particular wave ends up doing. That means having a basic emergency kit ready, enough water for several days, non-perishable food, a battery-powered or hand-crank radio, flashlights, extra batteries, a first aid kit, and copies of important documents kept somewhere waterproof and easily accessible. It means knowing your evacuation zone if you live in a coastal or flood-prone area, and understanding in advance where you'd go and how you'd get there if local authorities issued an evacuation order. It means making sure your phone and any backup power banks are charged, since heavy rain events, even from weak systems, frequently knock out power for extended periods. And for residents in mountainous or low-lying areas prone to flash flooding and landslides, which, as we discussed, is historically the deadliest hazard associated with slow-moving tropical waves in this region, it means paying close attention to local flood warnings rather than focusing solely on wind speed forecasts or a storm's official category. The second point is about information sources. During an active tropical wave situation like this, it's worth following official meteorological agencies directly, National Hurricane and Meteorological Services, rather than relying solely on secondhand social media posts, which can spread outdated or exaggerated information quickly. Official forecast updates typically come out multiple times a day during an active watch period, and checking directly with these sources gives you the most accurate, most current picture of where the system stands and what its most likely trajectory looks like. And the third point may be the most important one. Don't let an El Niño year create a false sense of security. Yes, this season overall has leaned toward being quieter than average because of the wind shear associated with this year's El Niño pattern. But as we discussed earlier, quiet seasons have still produced dangerous, even historic storms in the past. A below-average season number doesn't mean a below-average risk for any individual family, business, or community. It only takes one system in the right place at the right time to make this a memorable season for the people directly affected, regardless of what the seasonal totals eventually show. Before we move to the final part of this story, it's worth clearing up some of the terminologies you'll hear repeated over and over during a situation like this, because the words meteorologists choose are deliberate, and understanding them helps you interpret official updates more accurately instead of relying on second-hand interpretations. A tropical disturbance is the broadest, most general term. It simply means an area of organized shower and thunderstorm activity that meteorologists are watching without any implication about whether it will ever develop further. Every tropical wave is technically a type of disturbance, but not every disturbance started as a classic African easterly wave. Some form locally, within the Caribbean or Gulf itself, from old frontal boundaries or other atmospheric leftovers. A tropical depression is the first stage that comes with an actual classification number rather than just a description. At this point, the system has developed a closed, defined circulation at the surface, with sustained winds of up to 38 miles per hour. It's organized enough that forecasters can track its center with confidence and issue a formal forecast track. A tropical storm is the stage at which sustained winds reach 39 miles per hour, and this is also the point at which the system receives an official name from the predetermined list for that year. This naming isn't ceremonial. It exists so that communication about the storm, from emergency broadcasts to evacuation orders, can happen quickly and unambiguously without confusion between multiple systems potentially active at once. A hurricane is reached once sustained winds hit 74 miles per hour. And from there, the storm is further categorized on the familiar 1 through 5 scale based on wind speed, with Category 3 and above classified as major hurricanes capable of causing devastating, life-threatening damage. Understanding this latter matters because it helps explain why forecasters are so careful with their language around a system like the one currently in the Caribbean. Right now, it hasn't even reached the depression stage. Every step up that ladder represents a real, measurable change in the atmosphere, not just a shift in how dramatic the headlines sound. If this all sounds familiar, a wave crossing the Atlantic, uncertainty about development, forecasters urging preparedness without alarm, that's because this exact scenario plays out repeatedly throughout every hurricane season, sometimes multiple times, in a single month during the peak stretch from August through October. It can start to feel repetitive, even a little exhausting, especially for people who live in the region year after year. But that repetition is actually the system working the way it's supposed to. The Atlantic produces dozens of these waves every season precisely because the atmospheric conditions over West Africa that generate them are remarkably consistent throughout the summer months. Most of those waves genuinely do fade away without consequence, and forecasters know this well. The reason they still track every single one carefully, issuing regular updates even for systems given only a modest chance of development, comes down to a simple principle in meteorology. It's far better to watch 100 systems that turn out to be nothing than to miss the one that doesn't. This is also why you'll often hear seasonal outlooks described in terms of probability rather than certainty, whether that's an outlook describing the entire season as likely to run above or below average, or a specific system being given a defined percentage chance of development over the next 2 days versus the next week. These aren't guesses. They're calculated estimates based on decades of historical data about how similar atmospheric setups have behaved in the past, combined with the latest computer model guidance for the days immediately ahead. As the system evolves and forecasters gather more direct observations, those percentages get sharper and more confident, which is exactly the pattern we should expect to see with this wave over the coming days, whichever direction it ultimately takes. Let's bring this back to where we started. Right now, this tropical wave sits in an early, uncertain stage of its life. It has made the long crossing from Africa, survived dry air and disruptive upper winds along the way, and pushed into the warm waters of the Caribbean Sea, where it now faces the next test, whether the atmosphere around it will allow it to organize, or whether the elevated wind shear driven by this year's strengthening El Niño will keep it disorganized and gradually pull it apart. Over the coming days, forecasters will be watching several things closely. Does the associated thunderstorm activity begin consolidating around a single, definable center, rather than remaining scattered across a broad area? Does the system encounter a pocket of reduced wind shear as it continues westward, particularly as it approaches the Western Caribbean, where conditions have historically proven somewhat more conducive to slow development during peak summer? Does dry air continue to interfere with its structure, or does the atmosphere around it moisten enough to sustain deeper, more persistent convection? The honest answer is that nobody, not the most advanced computer models, not the most experienced meteorologists, can tell you with certainty today exactly what the system will look like a week from now. That's not a failure of forecasting. It's simply the nature of atmospheric science at this early stage of a system's life. What we can say is that the ingredients are mixed. There's enough warmth and enough persistence in this wave to keep it on the radar. There's enough hostile wind shear in the broader pattern to keep expectations for rapid, dramatic development in check, at least for now. What matters most, regardless of how this particular system evolves, is that it serves as a reminder of where we are in the calendar. We are moving deeper into the heart of hurricane season, a stretch of the year when tropical waves will continue rolling off the African coast every few days, each one a fresh roll of the dice, each one deserving its own careful watch. Some will fizzle quietly over open water and never make headlines. A few this year or any year will find exactly the right conditions and become the storms we remember. For now, the smartest thing anyone in the path of this system or any future wave this season can do is stay informed, stay prepared, and take these systems seriously from the moment they're first identified, not just once they earn a name. We'll continue tracking this system closely and bring you updates as new information becomes available. Until then, stay safe, stay ready, and we'll see you in the next one.